This is our February-March 2024 P3 variant 2 9709. So our question number 1 is about quotient and remainder. It's a simple long division question. So put this polynomial inside and x square plus 5 outside. So now try to bring x power 4 from x square plus 5. So multiply x square by x square to get x power 4. You have to focus how to bring x power 4. So we get x power 4 plus 5. So our first quotient is x square, and write down x power 4 plus 5x square here. Now change the signs. So x power 4 will be cancelled. So minus 3x power 3 plus 4x square minus 12x. Now try to bring minus 3x power 3 from x square plus 5. So we have to multiply x square by minus 3x to get minus 3x power 3, and then minus 15x. So write it down here. Change the sign. Minus 3x cube will be gone. Okay, I forgot to bring 27 down. Okay, now try to bring 4x square. So multiply x square by 4 to get 4x square. So you write it down here. Okay, now I write 27. So your remainder is 3x plus 7. And your quotient is x square minus 3x plus 4. Now question number 2, find the quotient of x square in the expansion of this. It's a binomial expansion question. So convert 4 minus x square root in the index form. So 4 minus x whole power 1 over 2. So actually we have to apply this 1 plus x power n, which says this thing. So convert 4 minus x in the form 1 plus x. So we have to divide 4 minus x by 4, and you have to multiply also by 4. So you write 4 power 1 over 2. So this becomes 2, 1 minus x over 4 whole power 1 by 2. Write it here. So take 2 at one side. Now expand 1 minus x over 4 power 1 over 2 with the help of this formula, which will be given to you in the formula sheet. Carefully write everything here and take care of the signs plus and minus. Okay, now we have to multiply 2 by 2x and the first term in the second bracket to get x square. And now 2 with minus 5 and also with the second expression in the bracket to get x square. Now simplify it. So this is the coefficient of x square. Part B says state the set of values of x for which the expansion in part A is valid. So this is also given in your formula sheet. So pick minus x over 4 modulus which is less than 1. Write it less than 1. Why? Because let me write it for you here, which is already written in your formula sheet. This expression where n is rational and x modulus is less than 1. So minus x over 4 modulus should be less than 1. Now simplify it from here. So x is less than, x modulus is less than 4. This is your answer. Question number 3. It is given that z is negative root 3 plus I. Express z square in the form r e power I theta, where r is greater than 0 and the range is from less than equal to pi greater than negative pi. So z square equals negative 3 root plus I whole square. So now open it with the help of the identity. So remember, I square equals negative 1. So now simplify it. So your modulus is r, your argument is theta. So z square modulus would be 2 square plus minus 2 root 3 whole square whole under root. Now simplify it. So your z square modulus would be 4. For argument, you make a sketch of it. 2 unit on the right and negative 2 root 3 downward. So you use tan theta. So your tan theta is negative root 3 over 2. Your tan inverse is negative root 3, which is pi by 3, negative pi by 3. So z square equals 4 e power negative pi by 3i. B part, complex number w. I read it as w, actually we can also read it as omega. So number w, complex number w is such that z square w is real and z square over w modulus equals 12. Find the two possible values of w, giving your answer in the form r e power I alpha, where r is greater than 0 and alpha is less than equal to pi greater than negative pi. Alright, we have to let w equal a plus bi. So z square w would be 2 minus root 3i times a plus bi. Now multiply these two brackets. You will get this. I square equals negative 1. Again, I am writing it for your memory. So simplify it. When z square w is real, then definitely imaginary part would be equals to 0. So 2b minus 2a root 3 equals 0. So from here make b the subject, which would be a root 3. Now z square over w modulus equals 12. So z square w modulus, z square modulus over w modulus would be equals to 12. So w modulus equals z square modulus over 12. So z square modulus is already we have calculated, which is 12. Which is 4 and 4 over 12, which is 1 over 3. So w modulus is 1 by 3. So w modulus is also a square plus b square whole under root, and w modulus is equal to 1 over 3. So we can say that a square plus b square root equals 1 over 3, squaring both sides. Now simplify it and try to be very attentive. So b square, in b square we should write a root 3 whole square, and that is equal to 1 over 9. From here we simplify it and we get the value of a, which is plus minus 1 by 6. By putting this value in to get b, so we get b equals plus minus root 3 over 6. Okay, now as w was let as a plus bi, so w1 is 1 over 6 plus root 3 over 6i, and w2 would be minus 1 over 6 minus root 3 over 6i. So if we make a small sketch to understand, so this is our w1 and here is our w2. So use tan theta for both. Argument of w1 is tan inverse of root 3 over 6 over 1 by 6, which is pi by 3, and argument of W2 would be equals to tan inverse of negative root 3 over 6 over 1 by 6, which is minus pi by 3. So you have to subtract minus pi by 3 from pi, and you will get this negative 2 pi by 3. So W1 can be written as 1 over 3 e power pi by 3 I, and W2 equals 1 over 3 e power minus 2 pi by 3 I. Question number 4. The positive numbers p and q are such that ln p over q equals a and ln q square p equals b. Express ln p power 7q in terms of a and b. So this is a logarithmic question. So ln p over q would be a, ln p, because p is divided by a, so this is a rule, logarithmic rule. If something is dividing by each other, so we have to subtract it. Ln p minus ln q would be equals to a. So ln p equals a plus ln q. I make ln p the subject. So ln q square p equals b. So they are multiplying, so we have to add them. Ln q square plus ln p is equal to b. So 2 ln q plus ln p is equal to b. Bring down the power of q at one side. So 2 ln q plus a plus ln q. I have placed the value of ln p, which was a plus ln q, here, and now from here you simplify it, because it has become ln q now. So 3 ln q would be equals to b minus a. So ln q is b minus a over 3. So now write ln p is equal to a plus b minus a over 3. Ln 3 is equal to 3a plus b minus a over 3. So 2a plus b over 3. So ln p power 7 q equals ln p power 7 plus ln q. So bring down the power 7 at the side. So ln p plus ln q. Now 7 times ln p is 2a plus b over 3 plus ln q is b minus a over 3. Now simplify them. 14. So this would be your answer, 1 over 3 bracket 13a plus 8b. Alright. Now question number 5. On a sketch of an Argand diagram, shade the region whose point represent complex numbers z satisfying the inequalities. Z minus 4 minus 2i modulus is less than equal to 3, and z modulus is greater than equal to 10 minus z modulus. So z minus bracket 4 plus 2i, because 4 minus 2i become 4 plus 2i, is less than equal to 3. This is radius. It's actually a circle of radius 3. So circle center 4 to radius 3, and z modulus is greater than equal to z minus bracket 10 plus 0i modulus. I have arranged this in the straight form. 10 minus z, I have written it like this. So this is the perpendicular bisector, and joining the point 0 0 from z modulus and 10 comma 0 from 10 minus z modulus. The perpendicular bisector passes through the midpoint, and midpoint would be 0 plus 10 over 2 and 0 plus 0 over 2, which is 5 comma 0. So now make a sketch. So I have written till 8, actually it should be written till 10, but it's okay. So on the y-axis I have written till 6, and below the x-axis I have written till -1. So this is your 4, 2 is this point, and now try to make a circle around this. So let me make it almost a clear circle. Okay, this is your x is equal to 5. Actually this is your perpendicular bisector, 5, 0. So make a straight line. So this is your theta, and theta is from your 0, 0, and your shade is from the from right side of the perpendicular bisector, because it says z modulus is greater than z minus 10 plus 0i. So that's it. Find the greatest value of argument of z for points in this region. So your greatest point, so you should know the equation of the circle, which is x minus 4 whole square plus y minus 2 whole square, because you know the coordinates of the center of the circle, and that is equal to 9. Actually your radius was 3, so square of 3 is 9. So x is equal to 5, so put the value of x5 in here, and you get the value of y. So this is your y is 2 plus minus root 8. So your greatest, you know, tan theta is 2 plus root 8 over 5. This is your 2 plus 8. So tan inverse is 2 plus root 8 over 5, and argument z is maximum at 0.76 rad. Now question number 6. In this question, actually this is an explicit part of the equation. So we no, this is implicit function. So we have to show dy by dx this. So you write 2y square minus 3x plus x equals x square. Now differentiate every part of it. But remember, when you differentiate y, you have to write dy by dx with it. So the second portion, take 3 outside, and xy will be differentiated with the help of product rule. So first function into derivative of second plus, so second function is 1, actually y, so I have to write dy by dx with it, plus second function as it is into derivative of first, and is plus 1, differentiation of x is 1, is equal to 2x. Now collect, first multiply 3 inside the bracket, so it becomes 3x dy by dx plus 3y and plus 1 equals 2x. Now take dy by dx as common, so it becomes 4y plus 3x, and is equal to 2x minus 3y minus 1. Now make dy by dx as a subject, so it becomes this thing, and you now compare it with the question. It's already shown. It's a 4 marks part. D part, hence show that the curve does not have a tangent that is parallel to the x-axis. So the gradient is 0 when tangent is parallel to the x-axis. So 2x minus 3y minus 1, which you have already shown, that is equal to 0 because it was dy by dx. So you are left with 2x minus 3y minus 1 equals 0. So from here you make x the subject. Now 2y square plus 3xy plus x equals x square. Now put the value of x here. Now simplify it. I am multiplying it by 4. So that the fraction would be gone. The question says curve does not have tangent, so b square minus 4ac. Let's see what it says. A is 17, B is 6, C is 1. Put the values in. So it's minus 32, so this is less than 0. It means there is no solution. Question number 7. Diagram shows curve y equals x e power 2x minus 5x and its minimum point m where x is equal to alpha. Show that alpha satisfies the equation alpha equals half ln 5 over 1 plus 2 alpha. So write it down, the equation. So now differentiate it. So first part is the product rule. So dy by dx becomes now take it e power 2x as common. Take ln on both sides. Ln is 1. So your x is 1 over 2 ln 5 over 2x. So x is alpha. So write in terms of alpha now. Okay, verify by calculation that alpha lies between 0.4 and 0.5. So your alpha is 1 over 2 ln 5 over 1 plus 2x. So your first value of x would be, alpha means x, so 0.4. So alpha minus 1 over 2 ln 5 over 1 plus 2x. So 0.4 minus 1 over 2 ln 5 over 1 plus this. Now simplify it. So your value is negative, so it's less than 0. So now put x is equal to 0.5. So your value is 0.04, which is greater than 0. So change of sign means that alpha lies between 0.4 and 0.5. Okay, in part C, he says use an iterative formula based on the question in part A to determine alpha correct to 2 dp. Give the result of each iteration to 4 decimal places. Okay, so this is our alpha, and our first value is from 0.4 to 0.5. So add them and divide it by 2 to get the first value of alpha, which is 0.45. So second value of alpha would be, you place 0.45 in it, use a calculator and to get the value, and your value is 0.4838. Now place this in alpha 3, you get this value. So still carry on, put this value in the alpha 4, still carry on, put this 0.4753 in alpha 5, you get 0.4707. You put this value in alpha 6, you get 0.473. Now write down all the values up to 2 decimal places. So first value is 0.48, second is 0.47, third is 0.48, fourth is fifth is 0.47, and the last one is 0.47. So stop here because you got the same value, 0.47 and 0.47. So you can say that alpha is 0. So we have to solve this. So write down this equation and equate it with r sine x plus alpha. So use the identity cos a plus b, which is cos a cos b minus sin a sin b. Actually this identity would be given into the formula sheet. So it becomes cos x cos pi by 4 minus sin x sin pi by 4. So this is equals to cos 1 over root 2. Cos pi by 4 is cos 1 over root 2, and sin pi by 4 is 1 over root 2. So simplify it, you get this. Now that entity sin a plus b is sin a cos b plus cos a sin b. So r is sin x cos alpha plus cos x sin alpha. So r is 1 square plus 2 square, which is root 5. So compare the coefficients of sin of x. So 1 equals r cos alpha. Compare the coefficients of cos of x, which is 2 equals sin r sin alpha. So now 2 divided by 1 will give you 2 tan of alpha. So tan inverse of 2, which is 1.107. So it becomes root 5, which was r sine of x plus 1.107. B part, he says solve the equation this, and the range is theta is less than 4 pi and greater than negative 4 pi. So this given equation is actually, if you see the previous main equation, it is double of that, means multiple of 2. So this equation is double of, or the multiple of 2 of the equation we dealt in part A. So this was our equation in part A. So our solution was root 5 sin x plus 1.107. So if I multiply this by 2, I will get this and replace x by 1 over 2 theta, and this is equal to 3. Now solve it from here. So sine is positive, so look at the quadrant where sine is positive, first and second quadrant. So basic angle is sine inverse of this. So theta is less than 4 pi, greater than negative 4 pi, so theta by 2 would give you 2 pi and negative 2 pi. So here our quadrants are, from the negative side we have to check these angles. So our basic angle is 0.73. So solve it with the theta by 2 plus 1.107. So minus, you have to minus 0.73 from 180, which is pi, and the clockwise is these. So pi minus 0.73 is 2.4, and the answer of this is minus 3.877, and the value of this is minus 5.548. So theta is 0.73. So minus 1.07 multiplied by 2, this will give you theta, which is negative 0.743. And the second one is 2.4. 0 minus 1.4, 1.107 multiplied by 2, theta is 2.598, and negative minus 3.877 minus 1.107 multiplied by 2, so this is minus 9.96, and the last one is minus 5.548 minus 1.107 multiplied by 2, this will be minus 13.31. So values within the range are minus 0.74, minus 9.97, 2.59 or 2.6 to 2 decimal place. Question number 9. Show that OABC is a rectangle. So let's draw the rectangle OABC. AB equals OC. So this is the diagonal OB. So magnitude of OB square equals magnitude of OA square plus magnitude of AB square. So OB is 8 square plus 2 square plus 6 square, and this is 104 root. OA, magnitude of OA is 5 square plus 2 square plus 1 square whole under root, which is 30 root. OC, 3 square plus 4 square plus 7 square whole under root, which is 74 square root. So 104 root square plus 30 root whole square plus 74 root whole square, this is 104 plus is equal to 104, therefore OABC is a rectangle. B part say use a scalar product to find the acute angle between the diagonals of OABC. So again make the rectangle. So acute angle, I name it P, the center point. So cos of BPA equals PB dot PA over magnitude of PB times magnitude of PA. So PA is half of CA. So PA is equal to half of CA is OA minus OC. So OA is 5 minus 2, 1. OC is 3, 4 minus 7. Solve it. You get PA equals 1 negative 3 4. So PB is half of OB. So PB is equal to half of OB is 8 2 minus 6. Solve it and you get PB is equal to 4 1 negative 3. So now magnitude of PB is 4 square plus 1 square plus negative 3 whole square root. Now 26 root. This is magnitude of PB. Magnitude of PA is 1 square minus 3 square plus 4 square whole square root, which is 26 square root. So now cos of PBA is equal to 4 1 negative 3 dot means multiply 1 minus 3 4 over root 26 times root 26. So this become minus 11 over 26. So cos inverse of minus 11 over 26 is 115.03. We need acute angle, so subtract it from 180. So we get 64.97 or 65. Okay, question number 10 is a partial fraction question. So write it down. Write it a over 2a plus x plus b over 2a minus x c over 5a minus 2x. So 36a square would be multiply a by 2a minus x and 5a minus 2x plus multiply b by 2a plus x times 5a minus 2x plus c multiply c by 2a plus x 2a minus x. So now first eliminate a by picking 2a minus x is equal to 0, so x is equal to 2a. If you write 2a in x, your a would be eliminated. So b becomes this, put 2a everywhere where you see x. So here you get the value of b also. To get the value of c, so you pick 2a plus x is equal to 0, so x is equal to minus 2. By writing this minus 2, you get the value of a, which is 1. Alright, now to find c, compare the constants. So 36a square would be equals to 10a square, 9 into 10a square, c into 4a square. Just pick the constant values and simplify it. You get c. So your f of x would be 1 over 2a plus x plus 9 over 2a minus x minus 16 over 5a minus 2x. This is your final answer. B part, find the exact value of integral from minus a to a f of x dx, giving your answer in the form p ln q plus r ln s, where p and r are integers and q and s are prime numbers. So here we go. Write down the answer of the previous part. Now we have to integrate it. So first part is ln 2a plus x, because the denominator, differentiation of the denominator, you find it in the numerator. The differentiation of x is 1, you see the 1 in the numerator, so you can straight away write ln 2a plus x. So in the second part, the differentiation of this denominator is minus 1. So you take 9 at one side, so it becomes 1 over 2a minus x. So differentiation of minus x is minus 1. So you put minus here with 9. So then you can write ln 2a minus x. So it becomes minus 9 ln 2a minus x plus 8. How 8 is coming here? differentiation of minus 2x is minus 2. So you multiply and divide it by minus 2, you get 8 because 16 is in the numerator. So 8 times is 16. So your minus become plus. So 8 ln 5a minus 2x. So this is your, now put the limits from minus a to a. Now upper limit minus lower limit. First you say try to simplify it. This is your upper limit minus now your lower limit. Put minus a in x. Wherever you see x, you write minus a. Now you simplify this. So you get 18 ln 3 minus 8 ln 7. Question 11. Variable y and theta satisfy differential equation. This. It is given that y equals 0 when theta is pi by 4. Solve the differential equation and find the exact value of tan theta when y is equal to 1. Okay, you separate the variables. Separate y's at one side and theta's on other side. So you get this. So the left side becomes like this. So we have to use integration by parts. So 1 plus y, I write it as 1 and e power minus cy as 2. So the formula is first function as it is into integral of second minus integration of second into derivative of first. So apply this on 1 and 2. So first function as it is integration of second, which is this, minus integration of second, which is this, into derivative of first, which is 1. Now simplify this from here. I am not solving the other part. I will solve it later on. First let me complete this. I am taking negative 1 over 3 e power 3y as common. Now the second part. So 1 plus cos of 2 theta becomes 2 cos square theta minus 1. This is actually identity. So plus 1 minus 1 gone. So 1 over 2, you can write it outside, and 1 over cos square theta is secant square theta. And the integration of secant square theta is tan theta plus c. So you write it here with it. So you know that statement has been completed. Now when y is equal to 0, theta is pi by 4. So you write 0 in y and pi by 4 in theta. So you tan pi by 4 is 1. So your c is minus 17 over 18. So you put it back the value in the main equation. Now from here y equals 1. You put in 1 wherever you see y. So it becomes like this, simplified. So your tan theta would be equals to 17 over 9 minus 14 over 9 e power 3. This would be your exact answer. So that's it. Here is my phone number. I'm from Pakistan. Any queries, anything you want to know, just WhatsApp me on this number.